Ladies and gentlemen, good morning, good afternoon, good evening, wherever you are in this world. I am happy and proud to welcome you to another webinar of Vexcel Imaging. This webinar is all about our new camera system, the oblique camera system UltraCam Osprey 4.1. In the next about 45 minutes, Bernhard and myself will present you the latest news on UltraCam Osprey 4.1 and how the camera interacts with our software system UltraMap. Bernhard Schachinger is a specialist in our application team, and myself, Alexander Weikart, I'm the CEO of Vexcel Imaging, and it's great to welcome you here at this webinar. What we have prepared for today is the key specifications of UltraCam Osprey 4.1. Then we talk about how the new camera interacts together with our software system UltraMap. Then Bernhard will spend some minutes on data visualization, and then we have a question and answer session at the end of the presentation. When we talk about the Osprey 4.1, we are talking about our next generation camera system, and this camera system combines photogrammetric grade nadir image capture with high resolution oblique image capture. So with this setup, the camera covers a wide range of applications from city mapping to photogrammetric grade mapping projects. And that's in this wide range of applications you can do with one camera system. In the nadir part, the camera collects high resolution PAN, RGB and near infrared, and the PAN chromatic channel size has an impressive 288 megapixel footprint. In the oblique images, the camera is using RGB biopattern sensor with a resolution of 150 megapixels. In UltraMap 4.5, we introduced a new feature for the area triangulation. So the AT is not only done from the nadir images, but is also done by taking into account the oblique images. That has a significant increase in accuracy for nadir and especially for the oblique images, and so we are achieving an overall photogrammetric grade of accuracy in the camera system. That makes the Osprey a super precise measurement instrument for this wide range of applications like the city modeling, but also for the traditional photogrammetric applications. And that allows to process metadata such as point clouds, surface models, terrain models, and 3D tints. The very unique feature of the UltraCam Osprey is the pan channel. The camera is the only oblique camera system on the market which is using a high resolution pan channel, and this pan channel acts as a photogrammetric backbone of the camera system. That has a significant advantage in resolution compared to the use of RGB biopattern sensor, but also not only in resolution, also in accuracy and geometric precision. The camera is fully calibrated with respect to its geometry and also with respect to its color appearance, so with respect to the radiometry. All in all, that leads to an accuracy in the sub-pixel range for the whole camera system. And with that setup, the UltraCam Osprey is fully compatible with our photogrammetric camera lineup like the UltraCam Falcon and the UltraCam Eagle. The nadir footprint is determining the flight efficiency of the camera system, and here the UltraCam Osprey 4.1 has a really impressive footprint size. The footprint range is more than 20,000 pixels wide across the flight strip and more than 14,000 pixels wide along the flight strip. And that gives an utmost flying efficiency for this camera system, which is in the league of large format camera systems. The UltraCam Osprey 4.1 is the first camera system of our new fourth camera generation. Other sensors will follow over the next years. And with this fourth camera generation, we are introducing CMOS sensor to our camera lineup. The CMOS sensors have a smaller pixel pitch compared to the CCDs. So what we did is, for the fourth camera generation, we are developing a completely new set of lenses. And these lenses are again going the extra mile and are setting a new standard for lenses in aerial image capture. So just to show you a little bit, this is how one of the new sensors look like. Fantastic, I think. Yeah, so, and that is one of our new developed lens system. I got really one out of production, so this is not a fake, this is a real lens system, and if I drop this down, I drop down a few 10Ks of worth, and production will kill me because they can't manufacture one of the additional Osprey 4.1s, which we urgently need. So this is how it looks like, latest technology in sensor development, and here we have the latest development on lens systems. As I described, setting a new standard in aerial lenses, and they are designed so as we are with the fourth generation are going into a roadmap of sensors. They are designed not only to keep up with the current pixel pitch of the CMOS sensors, but these lenses are designed to handle also the upcoming new resolutions of CMOS sensors like we see it in the roadmap from the sensor manufacturers. So absolutely high-class lenses, and they will be now in our fourth camera generation. The lens system of the fourth camera generation, like we have here, one of it are a specific design and development for the UltraCam camera lineup, so nobody else can buy it, and we are really proud about these developments. We have done it with high-class lens manufacturer out of Germany, and these lenses are really exploiting the physical limits of what you can do with lens designs and technology to the absolute maximum. The result of all this effort is an unprecedented quality in the images with respect to sharpness, level of detail, and radiometric quality. We have not only developed new lenses, also the system concept of the camera has been changed. So in the UltraCam Osprey 4.1, the pan channel, the nadir looking cones for the pan channel, for the near infrared, for the RGB are oriented at the outer ring of the camera system, and the oblique cones are in the inner part of the camera, are looking crosswise, left and right and back and forward. And with this setup we are overall achieving an optimized field of view, and that limits the potential obstruction with structures of the airplane to a minimum and eases up the installation and allows the camera to be installed in a wider range of planes. The camera system has a frame rate of 0.7 seconds. To make this possible, we have developed totally custom electronics which are used to convert the data from the sensors and move it to the storage system. The technology we are using for the data handling is PCI Express, and that is now embedded in the camera system. And this custom electronic enables us to achieve this high data rate. There is a reason why we have done it. The combination of the wide footprint along with this very fast frame rate allows a huge flexibility for the flight missions. You can either leverage this fast frame rate by flying super fast, which increases your collection efficiency, or you can use this fast frame rate to increase your forward overlap, and that has an input and benefit in your AT, and then especially in the downstream processing of 3D products like the point cloud, surface model, terrain model by the dense matching technology. Just as an example what this means, assuming you want to fly a high resolution project, 2.5 centimeter ground sample distance, that's impressive, with 86% forward overlap. That is also impressive and ensures utmost quality in your 3D metadata. And you can do this with the Osprey 4.1 at 126 knots. That's an unbelievable high flight speed for such a combination of ground sample distance and forward overlap. Or another example, and that's how we currently operate the camera for our own VDP flying. We fly 7.5 centimeter ground sample distance with the standard 80-60 pattern, and we are currently doing this with the Osprey 4.1 at 225 knots. That is almost double the flight speed from what was possible with previous cameras. With the new CMOS sensors, we are also introducing a new forward motion compensation. The new adaptive motion compensation compensates for aircraft movement and also camera orientation and takes into account not only the flight direction but all other directions of the camera movement and compensate for it. The new adaptive motion compensation can also compensate for different ground sample distances at one capture. That is especially extremely helpful for the oblique cones, as usually at an oblique capture the scale across the image varies significantly from the closer part from the lower part of the image up to the upper part of the image, where usually the distances are large and the objects are far away. All this leads to a maximum of sharpness across the images. We also touched the housing of the Osprey 4.1, so the overall housing of the camera system became smaller if you compare it to the Osprey Mark III. That means it's an easier handling in many ways. It's easier to address multiple installation scenarios. It gives the operator more space in the aircraft, and it expands the usage to smaller planes. We also reworked the way the components are installed or oriented in the camera housing. So now it is easier to access the IMU from the top. And that means if you need to change your IMUs, switch it between different sensors, for example, this is now easier to access. And you can exchange the IMU of the UltraCam Osprey without the need of an additional boreside flight. We have also changed the way the adapter ring, or the way the cylinder is designed with the adapter ring. This gives now an easier mounting into the mount, which speeds up the camera installation. With this massive amount of data, of course, data storage plays an important role. We have also designed a new data unit. So this is how the data unit looks like. They became smaller in form factor, but bigger in storage volume. We have two versions available. One can now hold 8 terabyte and the other one can hold 16 terabyte. That's quite impressive in volume, but on the other side, the UltraCam Osprey collects so much data in such a short time that if you are on a performance flight with a fast plane, you can easily fill up at least one, maybe even two of these 16 terabyte data units per day. So that's why they are also in-flight exchangeable, and they come in this nice case, and it's very recommended to have at least one in spare during your flight, as you will be surprised how quickly the UltraCam Osprey 4.1 fills up these nice drives. The access is easy. That's no longer from the side like it was in the previous models. Also, the data units can now be accessed from the top of the camera system for easier handling, as the top of the camera system is usually very easy to have access to. There is a built-in kind of RAID system which ensures redundancy, but you have the choice to either switch it on or off, so that you can decide if you want to optimize on data safety or if you want to optimize on storage volume. With the new camera generation, we also restructured the content on the screens. And the most relevant information is now easier access through bars at the sides. Maybe it looks a bit like a gimmick, but it isn't. On the top of the camera head, you have also an illuminated Vexcel logo. but that illumination is super helpful during flight operation, because with one view it gives you an immediate feedback of the camera status and the health of the camera system. So depending on the colors and how the logo looks like, the operator can immediately identify if everything is okay or if there are any problems with the camera system. The serial production of the UltraCam Osprey 4.1 just started, and we are currently using the first camera for our VDP flying, and to gain experience with the camera system, to further do minor modifications, further minor improvements of the camera system. And the plan is to have the camera ready for the commercial market with the first quarter of next year. So this brings me to the end of my part of this webinar. I would like to thank you very much for the attention, and I'm now handing over to Bernhard Schachinger. Bernhard Schachinger is application specialist in our photogrammetric team, and he will now talk about UltraMap and the way how UltraMap interacts with the UltraCam Osprey.
Yeah, hi everyone. My name is Bernhard Schachinger. I'm working here at Vexcel Imaging in Graz. I'm an application specialist, and I'm happy now to guide you through this short presentation about our UltraMap software. Our UltraMap software covers the typical photogrammetric data production workflow. It is one single software solution to process the data from all UltraCam camera models. So if you know the workflow for one UltraCam, then you know it for all other UltraCam models as well. So for the old cameras, even starting with the X and X Prime, to the newer cameras, Eagle and even the Osprey. So UltraMap covers all for processing from nadir and oblique images. That means there is a reduced training effort for the operators to be able to handle data from all UltraCam cameras. The UltraMap workflow covers tasks from the raw data handling, the image post-processing, aerial triangulation, radiometric adjustment, dense matching and auto-processing, and the full 3D reconstruction. Let's have a look at the UltraCam software modules in detail. The UltraMap workflow starts with the raw data center, the RDC, and this tool allows a monitored and verified transfer of the raw data from the camera data unit to the file server. Once all the raw data is on the file server, then in the post-processing, the camera calibration is applied and the stitching of the images is done. Then in the next step, there is support for an automated project setup to get easily all the camera parameters into the project file, and also the path to the image files and so on. So the operator is very well supported with preparing all the input data, also ingesting the post-processed GPS IMU data. The next step in the workflow is the automated extraction of type points for nadir and oblique images if using data from the Osprey camera. If the nadir image of a capture event is located over water, then hardly any type points can be extracted for this image. But if the oblique images of this capture event look at land with texture, then the type point linkage of the obliques is used to adjust all images of the capture event, bringing benefit to the usability of imagery which is captured along coastlines. In this dataset, we see an example for capture events with nadir images over water, but through robust type points in the oblique images, the capture event is fully linked to the block, and the images of all viewing directions are usable throughout the workflow. Ground control points and checkpoints can be measured in all the images through an intuitive user interface. The operator starts with initial measurements for a point, and the software then tries to automatically complete the measurements in all candidate images, both nadir and oblique images. Finally, Type points, ground control points and GPS data can be combined in the bundle adjustment and image orientations are optimized. It is a full photogrammetric bundle adjustment for all viewing directions. That means all the nadir images and the oblique images, they are all adjusted in one run. And then finally, reports and exports to standard file formats of the exterior orientations are available. The next step in the workflow is the automated color balancing. The images can be inhomogeneous because of date and time differences of the image acquisition or changing weather conditions, resulting in brightness differences between neighboring images. Differences might also exist because of merging data from various UltraCam camera models, and thus flight lines might look different. UltraMap tries to automatically reduce these differences and ensure a homogeneous brightness across all images. So the color balancing results are shown on a low resolution orthomosaic, which allows to switch from unadjusted imagery to the balanced results to see the benefit of this process. The idea of the radiometric adjustment in UltraMap is to first run the automated color balancing of the block, and then to do some manual adjustment of the preview orthomosaic, so that is the result of the color balancing. And all the adjustments done on this orthomosaic, they are also applied to the single images which are still underlying in the background. And then finally, there is the last step to do some fine-tuning of the single images to meet the needs of a specific project. And then, of course, all the adjusted images can be exported to standard file formats. The next step in the UltraMap workflow is the automated dense matching. The DSM can be visualized in UltraMap and quality control can be done. And then, if there are regions for editing identified, then we have a 3D editor for an efficient and intuitive user interface to interact with the DSM. Based on this DSM, UltraMap includes then tools to automatically create a DSM orthophoto, a true ortho. And then the next step is the integrated filtering from the DSM to the DTM, which is then used for DTM orthophoto generation. So that is the traditional orthophoto, an orthophoto which includes building lean, in contrast to the true orthophoto that we are processing based on the DSM. Of course, UltraMap includes also tools for seamline editing, and we are using all our images with full 16-bit in this workflow. So all image information is available until the final end product, and along with that we are also processing the RGB and the near-infrared channel, always in parallel, always consistent processing for all 4 bands, so that the full data quality is available until the final product. Only when exporting the data, the operator decides what kind of data to generate in standard file formats. The final step in the UltraMap workflow is the full 3D reconstruction. This step produces a 3D texture tin and a colorized point cloud. The software is able to flexibly use the imagery that is available within the workflow. So if using a nadir-only camera, we can use these images for the 3D data production, or if there is data available from an oblique camera, the Osprey, then we can of course use the nadir and the oblique images. The 3D data is visualized in UltraMap and can be exported to a wide range of formats, and more formats are of course planned in the future for the export. The general idea of the UltraMap workflow is to process the full data set at 16-bit and always use all 4 channels, so the RGB and the near-infrared channel, throughout the entire workflow to ensure the data products are always of the highest possible quality, and all 4 bands are always treated in a consistent way and do not show any differences. So the operator should then always decide at the end what to export, and therefore has the greatest flexibility and does not need to choose at the beginning of the workflow what kind of data products to generate. Our new camera, UltraCam Osprey 4.1, is fully supported by UltraMap and brings benefits to all stages in the workflow. The superior quality of the sensors and the lenses reduces the effort for radiometric adjustment and makes crystal clear imagery with vivid colors easy. The high frame rate of the camera facilitates image acquisition with high overlap, which brings benefits to the entire processing workflow. So, first big benefit is for a robust aerotriangulation result. Then we get a high quality DSM, and of course the 3D reconstruction is much more detailed than with lower image overlap. Now a few general features of UltraMap. UltraMap supports distributed processing. So that means UltraMap can run on hardware of almost any size and configuration, ranging from a single laptop to a high-end data center. So UltraMap can be adapted flexibly to almost any project and time frame as needed. Within the software, we have a tool called the Job Monitor, which helps to manage the processing system and allows to balance the load and keep track of all data that is being processed. There is an easy tracking of all the processing steps of a dataset throughout the full workflow. So the UltraMap Studio application allows to document all stages and all actions that have been done. UltraMap provides flexible licensing options, so that means you can either permanently purchase our software or you can subscribe to an UltraMap license on a monthly basis. The licensing is based typically on the number of CPU cores and the number of GPUs that are usable for the processing. On the other hand, the front ends that are used by the operators for interacting with the data, these are not limited in any way. That means that a number of multiple projects can be handled at the same time within the production workflow. So that was my little overview of the UltraMap workflow, and now I'm handing back over to Alexander. Thank you.
Bernhard, thank you very much for this great presentation. This now brings us to the end of what we have prepared as presenters, and we are now happy to open up the question and answer session. For the Q&A, please be so kind and type your question into the Q&A window of Zoom. So hi, ladies and gentlemen, this is Alex speaking, and we are now opening up the Q&A session. We already see some questions coming into the Q&A pane, so please be so kind and continue typing in questions, and we are happy to answer them. So I'll just start from top down. Is the new Osprey 4.1 using the Sony MIX411 150 megapixel sensor? The question is yes, we are using this sensor for our oblique RGB cones and also for the RGB nadir cone. What is AMC? What is adaptive motion compensation? Is it a mechanical FMC or electronic TDI, or just using ultra short exposure time? It's none of it. So we are not using a mechanical FMC, as the effort to move reliably a CMOS is huge, and this would introduce mechanical components into the camera, which are bound for wear and tear. Electronic TDI is currently not yet possible with CMOS technology, so it's also not electronic TDI. But using ultra short exposure time is also not the solution for it. There are cameras which label this as a kind of forward motion compensation, but honestly, that's not true. You would lose a lot of the benefit of the higher CMOS sensitivity if you just do this. So I explained a lot what it's not. So what it is a software solution. So we are doing a forward motion compensation in the processing of the data. As we are currently underway to patent the solution, I can't talk about the details yet. But as it is a software-driven approach, it allows us to compensate multiple angles and different scales during the post-processing. Can you give us an estimated price of the Osprey 4.1? Of course, always depends on options. The camera system by itself is roughly about 750k euro. After years using the successful and effective syntopic exposure configuration with 4 lenses and 9 CCDs, are you going to introduce simpler configurations with 1 or 2 massive CMOS sensors in your high resolution vertical camera range too? Clear question here is no. If we look on the camera lineup for our 4th camera generation, we introduced now the first one, which is the Osprey. Next will be Condor, and next after that will be the UltraCam Eagle. And the UltraCam Eagle will continue to use this very successful UltraCam system concept. So also with the Eagle 4.1, we will be using 4 lenses and 9 imaging sensor. In this case, it will not be longer 9 CCDs, it will be 9 CMOS sensors. But the concept of this syntopic exposure continues to stay in our high-end flagship in the UltraCam Eagle 4.1. Gruber and Murik published at ASPR 16 that they still saw huge advantages in CCD sensors over CMOS and considered CCD technology superior to CMOS. Does the Osprey 4.1 mean that now you consider that CMOS technology is mature enough to be used in high resolution aerial imagery? A short answer to that, yes, this is the case. CMOS technology evolved very much over the past 4 years. And if you look on the roadmap of the CMOS sensor manufacturers, a lot of improvements will happen in the near and far future. This is why we see the move from CCD to CMOS now suitable also for the high-end aerial cameras. Are there sample data of the UCO 4.1 available? We are working on it. It will be available soon, so please ping us by email, and we are happy to contact you and get you the data set as soon as it's available. There are a paper available which describes the AMC. This is often required for public tenders. Not yet, we are working on it. As I mentioned, we are also patenting the solution, so we need a few more weeks to stand still on that before we can publish officially any information about the AMC. But then, of course, it will be available. Also here, if you are interested, if you need it for tenders, please contact us. We're happy to send it. Can we expect CMOS-based medium format cameras in the near future? Yeah, that's a detail of our roadmap where we don't want to talk too much, but clearly there might be a benefit in going into a smaller lineup of the UltraCam sensor and combine it with the very powerful UltraMap, so might be possible. If ordering the camera, what is the delivery time? So we are now taking orders for the camera, but the production line is fully sold out till the end of this year. with the usage of the cameras for VDP. So the next cameras available for commercial business will be first quarter of 21. So in roughly 4-5 months from now, ready to be used for the flying season 21. Can we do resampling with UltraMap? I'm not totally clear about the question. I'm assuming that you mean resampling the resolution to other ground sample distances. That is not originally possible with UltraMap, as we are using the raw imagery as is, and we are a strong believer that doing resampling might destroy some of the photogrammetric accuracy, and it's not really needed as in the nadir part, thanks to our exposure scheme with the totally nadir cones and the syntopic exposure. We have absolutely rectangular pixels, and we don't need to cheat here. Having said this, there are features for increased resolution, enhanced resolutions available for the RGB channel. Can the Osprey be used in pressurized planes? I'm struggling with this question. In general, UltraCams can be used in pressurized planes, but due to the viewing angle of the oblique cones, the pressurized glass introduces higher artifacts and distortions in the accuracy compared to a purely nadir camera, so that needs to be tested. In general, yes, but it might degrade the accuracy in the oblique channels. But with that question, I'm also looking at Bernhard and checking if it made sense what I have just answered. Bernhard, do you have an opinion on the pressurized planes?
I fully agree to that. So technically, there is no limitation to operate the camera in the pressurized plane platform. However, the cabin glass that adds to the optical path, so there might be some risks to especially the oblique camera cones. So this needs to be verified for sure before going into any production projects with such a setup.
Thank you, Bernhard. Thank you. Next question. Thank you very much, Alexander, for your answers. I understand that some of the questions could still be confidential. Hey, it was a pleasure, and thank you very much for you have raised a lot of good questions, so thanks for asking them, and some of them will be answered over time. Will UltraMap be open for other cameras? That's work in progress. So the answer is yes. Time frame not totally clear. Potentially over the course of 2021, there will be import modules to support other cameras. Can we do resampling of produced data, such as sampling of ortho and DSM? In my understanding, the question is no, but again, Bernhard, please weigh in for that question.
Yeah, so for the processing, we are using the imagery as it is available for the input to the project. But when exporting the data, then we provide some flexibility to configure the DSM and the orthos. So if flying, let's say, with 10 centimeter ground sampling distance, you could export the data at 20 or 30 or whatever ground sampling resolution. Of course, you are not able to upsample to increase the resolution of the images of the data for exporting, because we cannot generate any new content to completely new class of ground sampling resolution. Yeah, there is some flexibility for the configuration of the produced data.
Thanks, Bernhard. Next question is, I would like to ask a color balancing problem of UltraMap when I use block radiometry to adjust color of the whole block of a photo. The color balancing effect only can apply to the photos within the mosaic area. Bernhard, please be so kind and wait again in here. If it's a short answer, if it's a longer answer, I suggest to take this offline and run it through the support team.
Yeah, so I see that this question is related also to the following messages. So also the next few messages have the context of the color balancing. So in short, this question is related to our procedure of running the color balancing first on a low resolution DSM and orthomosaic of all images in the project area, and then doing the adjustment for this low resolution overview ortho and transferring all the information back to the single input images. Due to the nature of this algorithm of being dependent on the low resolution DSM, there's a limit of all the pixels to be treated at the border of the project area where there is not enough image overlap to fully create the DSM. We are aware of that. So there are tools within UltraMap that allow you to handle these border regions now and to reduce these effects. And on the other hand, we are aware of that. We know that there might be some improvement of the algorithms be required. So we have that on the list, on the roadmap to improve in future versions.
Thanks a lot, Bernhard. So I think that answered a set of questions. I'm not sure. There's another at the lower end. Are there any plans to introduce more tools to adjust the radiometry, such as saturation? Can you give a comment on that, please, too?
Mm-hmm. Yeah. So I cannot yet give any details for this particular question here, but we are talking about new tools and new possibilities for adjusting the radiometry. So we definitely see that as an important point for the future roadmap, and additional tools will come in future versions.
Thanks, Bernhard. Another question for the raw images. I would like to export the raw images with the color balancing effect. Can you comment on that?
Mm-hmm. Okay. Yeah. So the image data that can be exported, including all the color balancing, or it can be exported without any information from the color balancing at all. So we can export the images like raw. So then it's basically just a conversion to the TIFF file format. Or you could do some manual adjustment, let's say modifying the histogram, gamma, or whatever, but not using color balancing. Or you can do the full range of adjustment possible. That means adjusting or applying the color balancing and adjusting all the image parameters and then exporting the data. So all that is available, and all that can be used in a very flexible way.
Thanks a lot, Bernhard. And for the next questions, again, I need your help, please. We have some questions concerning the combination of light altitude and ground sample distance. So for 10 centimeter, 2,128 meters. For 7.5, it would be almost 1,600 meter. And for 25 centimeter, the flying altitude of the Osprey 4.1 would be 530. Question mark. Can you comment on that? I would need to run my project calculator to answer these questions. Do you know it out of your mind, Bernhard?
Yeah,
that sounds right.
I would need to do the calculations as well. I don't have the numbers right here at the moment, but these numbers sound quite okay. I'm just checking here in a document in parallel, So yeah, here I find now my number for 10 centimeters. So that is exactly 2,128 meter flying altitude. So that's perfectly fine. So that derived numbers, these are also okay.
Yeah, excellent. Thank you. Is UltraMap also using the oblique imagery for type point collection? How is the AT for oblique images done? Is there a separate software required? Bernhard, I'm handing over that question to you, please, for answer.
Yeah, so UltraMap is using the oblique images, yes. So if the data is captured with the Osprey 4.1 or also with the Osprey from the previous generation, this does not matter. Oblique images are always treated in exactly the same way. That means for the type point collection, the operator can choose, depending on the project, if only nadir images should be used, or if all nadir and oblique images should be used. Or then we have one step which means a little bit reduced processing time, that is using all nadir images and just a subset of the oblique images to get a faster solution. So there is no separate software required for handling the oblique images. Full handling of all oblique data in the post-processing step, error triangulation, radiometric adjustment, and so on. All that is fully integrated in the UltraMap software.
Thank you very much, Bernhard. So next question is, does UltraMap support processing other imagery? And the answer is not yet. So UltraMap for the time being is absolutely tailored to UltraCam and does not process data from any other sensor. But that is an ongoing discussion inside our teams, and we might see input filter for other cameras coming over the next year. What is the delivery time for the camera? So the Osprey 4.1 is already in serial production, and the first lots are being used by ourselves to fly the VDP program and to test the cameras in depth. The cameras for commercial market will be available during early first quarter, starting January, February of next year. So they will be ready and available for flying season 2021. Can you give us a price estimation of the UCO 4.1? Depends, of course, a lot on the option, but roughly 750,000 euro. Is the motion compensation mechanical movement of the CMOS sensor? Answer is no. That is something we have not implemented, as we don't think that this is a really good solution, as it adds mechanical inaccuracies to the imaging sensor. So it is a software-driven solution which is specifically developed by us and also adds to our IP. When producing point clouds with our Eagle, we get 3 layers that we have to clean up. What does the raw point cloud product look like from the Osprey? Bernhard would love to hand this question over to you for answering.
Yeah, happy to answer that. So there are 2 points in the software where we can export point clouds. So the one is from this path going to the DSM production and then exporting points from there. The other path is when producing the 3D model and exporting the points from that result. So for the first option, the point cloud consists of all the points that were matched by the software based on the given input imagery. That means that this point cloud is richer than the DSM, so it does contain a few points above and below the surface that is finally in the DSM, in the raster data set that you can view and export. So that might need some adjustments or some cleaning before using for some application. On the other hand, when using the point cloud from the 3D workflow and from the 3D export, that is the representation of the reconstructed 3D surface. So roofs, walls, facades, streets, all that. And for that data set, some filtering has been already applied. Therefore, this one is cleaner and does not have that thickness. Yeah.
Thank you, Bernhard. Next question is, can the camera be installed in pressurized aircraft? I would say in general, yes. But as with all oblique sensor systems, this needs to be carefully tested because we also have oblique sensors which are tilted. The impact of the glass to the accuracy of especially of the obliques is higher than in a purely nadir camera. So the answer is yes, but we should test it to avoid reflections or inaccuracy in the geometry. Next question is it possible to install the current UltraNav system in the new fourth generation camera, or is it needed to upgrade the hardware of UltraNav? The answer is yes, it can be used, so no need to upgrade. So if you have an UltraNav, or if you want to swap, then it can be used. Is the sample data UCO 4.1 available? We are working on it, will be available soon. If you're interested, please contact us by email and we are happy to come back to you once we have the data set. Okay, another question, same content, can I get sample data? Yes, of course, please contact us so that we have the total point of contact and we'll get it as soon as possible. Can the camera be used in nadir only mode? That's not possible, so it's not possible to switch off the obliques. So when an exposure has been taken, then all cones, including the oblique cones, are exposed and the data is being collected. So I think currently my question, okay, now I see. Can the IGI, CCNS, FMS be used? It can be used as an external system. That's possible. Is the 3D production workflow only available with Osprey cameras, or can it be used with the Eagle data? Of course, it can be used also with the Eagle data, with the Eagle and also with the Falcon and also with the X and the X Prime and the L Prime. So that workflow is consistent and backward compatible. So you can enjoy this this workflow by using it with all UltraCam cameras. Bernhard, that's correct. Anything you want to add to that?
Yes, fully agree. So we support both oblique and nadir cameras in the 3D workflow, yes.
Great, thank you. Any plans to look into release medium format cameras? We're currently actively looking into that topic. That's the detail of our roadmap. I can't say more, but we're actively looking into that. Are there differences in size and weight from the Osprey Mark III? Yes, yes, they are. So we completely reworked the housing of the Osprey 4.1. So the camera is lighter compared to the Osprey M3, and also the housing is different. It has a little bit a bigger diameter of the lower part of the camera cylinder, but it still fits in the GSM 4000, for example. But then the head of the camera is considerably smaller, especially the upper part of the head. So that makes it much easier to install the camera in places or in airplanes where the hole is not in the center but moved to the left or right towards the body of the plane. And another important difference is the lens configuration, or the way the cones, the oblique cones are mounted. The Osprey M3, they were outward looking. In the M4.1, they are pointing inwards in a kind of a cross, Malteser cross configuration that also makes installation much easier as it avoids that the cones look into the structure of the plane. Okay, nice comment, thank you. Hey guys, thank you very much for listening. So, thank you for the excellent presentation, very good videography and audio quality. Congratulations. Wow, very kind. Thank you very much. Thanks for attending. Does the DSM generation use the oblique imagery along with nadir imagery? I would say, Bernhard, you already answered that. The answer would be yes, but please provide details, Bernhard.
Yes, we provide two paths for the 3D reconstruction in our software. So the one is for processing the DSM. We use the nadir images only to get the best processing speed. For the DSM, as it is a 2.5D data set, there are no details about facades and such included. Therefore, nadir imagery is fine. In contrast to that, when going to the 3D world, when the 3D mesh is the desired output, then of course we are using the oblique images along with the nadir images to get the best possible details and the best possible reconstruction quality. However, of course, quality costs some processing time. Therefore, we allow the user to choose which path to go. Yeah, the investment in processing time, that depends on the need for the output product.
Thank you, Bernhard. Another question, do you have true author output from your workflow? Yes, we do have. So in the awesome pipeline module, we can either do a projection based on the terrain model, on the DTM, that gives the classical standard author imagery, but we can also do a projection based on the DSM, and this leads to what we call DSM author image, or another word is true author image. So answer is yes. Bernhard, any details to be added?
That's it. Yeah, that's fine.
Yeah. Good. Thank you. How is the geometric calibration of the oblique cones done? Is it done relative to the position of the nadir cone? Bernhard, I would love to forward this question to you.
Yeah, each of the camera cones is calibrated in terms of all the interior parameters. So that is true for the nadir camera cones and the oblique cones. And then in addition to that, we are estimating or measuring the offset from the nadir cone center. So that is also being calculated from all the calibration images in our laboratory. In addition to that, we provide optionally a tool in UltraMap AT in the bundle adjustment section, where these parameters can be estimated by the software based on the project data. So that means the eccentricities, these can be estimated based on the project data and are being applied to all the processing in this project.
Thank you. What about the new capabilities to use LiDAR data with oblique images in the same workflow? How this can be cost-effective compared to the integrated system combining both imagery and LiDAR sensors in the same platform? Yeah, so the UltraMap workflow is clearly designed for image processing. UltraMap can be combined with LiDAR, but that will be a two-hole system, and it will be two independent workflows. We feel that gives superior solution compared to the integrated system, because the integrated systems always are a compromise, either underperforming camera or underperforming LiDAR. So combining the UltraCam with an external LiDAR system gives the optimized solution and utmost quality on both on the LiDAR dataset and the imagery dataset. From operation experience, what minimum aircraft hole size is required, and how close does the lens have to be to the outside skin of the aircraft? Does exhaust gas from single-engine aircraft present a problem with the oblique imagery in particular? So, in my understanding, a 19-inch holes would work with the UltraCam 4.1, but this is a very specific question on aircraft installation. So how close the lens need to be to the outer skin depends so much on the design of the airplane, where the wheels are and so on, that there's no general answer to that. Does exhaust gas from single engine aircraft present a problem? Yeah, that is an issue which, that's a situation, a scenario which need to be addressed. So many single engine planes have extended exhausters to avoid that the exhaust comes directly out of the engine. So that needs to be taken into account. But that's not specific to the UltraCam Osprey 4.1. That is specific to area cameras, and Oblique, of course, present an additional challenge due to the big field of view. Okay, thanks for the excellent presentations and professional answers. Thank you for that very nice feedback. Is there any classification applied to point cloud at stage 1 or stage 2? Ronald, question for you.
Yeah, so classification for the point cloud cannot be done in our workflow as you would expect it from a point cloud captured with a LiDAR system. So that is because of the different technology being used. One point cloud comes from LiDAR, the other comes from photogrammetry. However, the point clouds that we can export, these have RGB values for the points, and optionally we can also integrate the near infrared. So that information is available. So that could be used then in third-party software to do analysis or to do classification as needed. So the near, especially the near infrared, that's very helpful to do some classification on the data. In addition to that, we allow we provide a parameter for the export. When writing the point cloud out of UltraMap, then you can specify with a parameter the outliers to tolerate or outliers to avoid being exported. So that is also some tool that is available for fine-tuning the export from UltraMap.
Thank you, Bernhard. Do you provide for a system rental model? If not now, what time frame are we looking at? So it's possible to rent UltraCams. This is possible with was possible with all previous models, and we will also offer this for the Osprey 4.1. I doubt that we will do this in the first quarter of 2021, because we are already getting a significant interest in that camera for purchase. So literally the first batch of commercial systems are for sale, but over the course of 21, we will offer this for rental too. Do you have an estimation of the gain of efficiency for the same project between Osprey Mark III and 4.1? Yeah, so the efficiency gain is really, really significant. If you do just the comparison of the footprint size, the Mark III has 14,000 pixels across, and the Osprey 4.1 has 20,000 pixels across. So this is a more than 40% efficiency gain. That is huge. That is absolutely huge. But the Osprey 4.1 is really a beast. So if you can also change your flying platform and utilize faster planes, then you can gain double the efficiency compared to the Mark III, because the Osprey 4.1 has not only a 40% wider strip, it has also a collection rate of 0.7 second, which is more than double as fast as the Mark III. So if you combine it and use a fast plane, you achieve around double the flying efficiency. This is what we see currently in our own VDP projects. We started with the M3 and now are moving our own flying to Osprey 4.1, and the efficiency is just breathtaking. What's the power consumption with the 4.1? Yeah, I don't know this out of my head, so I'm not sure, Bernhard, Angelika, do you have the opportunity, or Katrina, to look on our specifications and provide the answer on what the power supply is? I think it's about 350 watts, but I might be totally wrong, so please have it, look it up.
Yeah, it's 330 watts in average, 350 peak.
Thank you, Bernhard. Great. And next question for you: what's the bias base to height ratio for the U041?
I don't have the numbers here right now, but we can definitely follow up on that with some numbers.
Okay, so please drop us an email, and we'll come back to you with the answer. Very nice comment. Congratulations. Yeah, let's have a drink on that. So there's also one pending question from which came from through the chat and not from the Q&A pane. From where will get it training? Not completely sure how to understand that question, but there's always the possibility to get training. For specific training, please contact us, contact our support team, or contact the sales team, and we will set up, or we will talk and address it and set up an appropriate training for you. All right, so I don't see any more questions in the Q&A pane. Let's wait for a few more seconds to see if something comes up. In the meanwhile, I would like to thank you, dear attendees, for attending this webinar. I do hope that you found it valuable, and also a big thank to Bernhard as a presenter, and also to Angelika and team for setting up the meeting. There's no questions to come up. Hey, thanks again. It was great talking to you, and I do hope that we can all meet in person soon again. Take care and have a great day, a great evening, a great morning, wherever you are in this world. Thank you. Bye-bye.